Hello and welcome everyone to today's webinar. Maybe it's your SQL or PL SQL, learn monitoring and performance testing of your ORDS REST APIs. Thank you for joining us. My name is Tara Van Cleve and I am a marketing event manager for the developer initiative here at Oracle. Today, we're excited to show you how you can ensure your ORDS REST APIs are high performing and stay that way when your traffic and application load increases. We'll also be recording the session and you'll receive the recording via the same email that you registered with. If you have any questions during the webinar, please drop them in the Zoom chat and Q&A areas and we'll be ready to help answer them. We've also set up a channel in our developer public Slack called Webinar ORDS REST APIs that you can access at the QR code or at bit.ly/odevrel_Slack. We'll leave the channel open after the event to contact us directly with any questions and to share resources. Today's webinar will be presented by Jeff Smith, Distinguished Product Manager, Chris Hoyna, Senior Product Manager, and Zachary Talkie, Senior Product Manager. So without further ado, I will hand it off first to Jeff.
Welcome, everyone. Thanks for joining us. We want to do a lot of practical how-to tips and tricks content today. I'm going to start off with a very, very brief overview of just ORDS and REST APIs to get everyone on the same page. Then show how to find the offensive code that's causing your REST APIs not to be as fast as you want them to be. And then we're going to hand over to Chris, and he's going to show off a few different popular load testing tools out there. So Oracle, I think, has one of the most connected databases, technologies, platforms in the market today. You've, of course, got all of your drivers out there supporting popular frameworks and programming languages. But on top of that, we've also got our native REST API features. And with our latest version of ORDS, we're now also supporting GraphQL queries. So we try to make it as easy as possible for developers to build compelling solutions on an Oracle database. And keeping all of the ACID principles intact, whether it's SQLnet JDBC or whether it's HTTPS and a REST API. So ORDS is our Java mid-tier tech. It's the Oracle Free Terms user license and has lots of features. So all of our Apex customers are using ORDS to deliver their Apex apps. We have the REST APIs and GraphQL queries. So pull a resource out of the database. Instead of going through the database using SQL, I'm making HTTP requests to the web server, and it's doing the work for me, and it's coming back as a JSON response. And we support all of the data types in the database, including things like spatial. So SDO geometry gets correctly represented in the JSON document. I didn't have to write any code for that except for the select statement. Brand new, we've now got support for GraphQL. So this is not what this webinar is about, but if you're interested in learning more about this, you can go read the What's New docs for ORDS 23.3, and I've got a couple of blog posts on thatjeffsmith.com. SQL Developer Web, we take what you like in the desktop, we put it in the browser, and it's also the primary integrated development environment for coding your REST APIs. Although you can still use the PL SQL APIs if you want. We have our database management REST APIs, so you can clone databases, monitor the database, pull out ASH, ADM reports, all kinds of good stuff there. And some of these monitoring features you could theoretically use to help find your slow-running REST APIs. We've got Soda for REST, and also we have the MongoDB API. So if you want to treat the Oracle database as a JSON document store or migrate your Mongo database apps over to Oracle database, ORDS can make those things possible as well. So in our managed environments in Autonomous, we have lots and lots of customers doing lots and lots of REST APIs, like over 1 billion HTTP requests are served weekly in that fleet. And most of those requests are REST API calls that customers have written and deployed. And here's just a small sampling of customers doing that kind of stuff in Autonomous. What is REST? It's an architectural style. It allows us to describe and interact with things in the database that we've modeled as collections or items in a collection, and we have verbs that we use to interact with these things. I can get something, I can remove something, I can put something in the database or the system, and I can also make changes to those things. It's almost always, or it is always, communicated or exercised via HTTPS, but the main thing I want y'all to take away on this description is just because you're using HTTP doesn't mean that you're doing RESTful requests or that you're following the REST architecture. So we're stateless, we're interacting with objects, with verbs, we're always including links wherever possible. So you need to keep those things in mind to generate and deliver REST APIs that are developer friendly. And if you do that, if you do provide really good APIs, then you will literally draw people to your ecosystem. Partners, customers, other people in your company will want to build upon the things that you've given them in the form of these APIs. But what we don't want to happen is have them all come to the party and then try to use your APIs and they're slow or they're not performant enough. So that's what this session's about, is why are they slow? How can we fix them? And how can we verify that these fixes are actually going to work once we roll them to production? So we don't really have a go faster button, but we do have some techniques. There's some ORDS specific features that you should be aware of. Probably the biggest pitfall or the easiest pitfall to fall into is around authentication. So for example, if you want to do basic authentication and you want to rely on database credentials to gain access to a REST API in the Oracle database, while that's easy, it's not great security practice. You probably don't need to share database credentials to people using your application. They want application level credentials. But if you do go basic versus OAuth 2, you're going to suffer a performance hit of something like a factor of, 200-300%. So if you use the OAuth 2 workflows, we no longer have to make literal database connections to see if your username and password are valid. That takes a lot of time. Using the OAuth 2 workflows, much, much faster. And in ORDS 23.3, we now also support JSON web tokens. So you can offload the complete authentication authorization process to third parties like an OCI. You can offload to IDCS or IAM. You could offload to Azure Active Directory. You could offload to Okta's OAuth 2. But I'm not here to talk about that. That would also be faster. If you want to learn more about this, it's also in the ORDS docs. We have features like entity tags. So if I've got a REST API that takes a long time to run or takes a long time to deliver a large payload to the client, and that payload is often not frequently changing, you're wasting a lot of effort to go, refetch that data every time someone hits the refresh button on their app or their web page. For example, if I'm getting a Wikipedia article on a topic that doesn't get updated every 10 seconds, and it takes 2-3 seconds to pull that down and someone's hit refresh. If you have an entity tag set up, ORDS can tell you, hey, that resource hasn't changed since the last time you got it, and you can avoid the whole round trip again. You can just keep what's in your locally on your client. Now, when you're building these REST APIs, we by default set the entity tag type to a secure hash. So when you have a select statement or a PL SQL program that returns a ref cursor, before we send that payload back down to the client, we compute a hash on that payload and include that in the response. If your apps aren't using that, that's work that's being done that you're not taking advantage of, and you might want to set that to none. If you have some use cases where you think you could take advantage of that, then you might want to code your apps to, take advantage of those entity tags to avoid doing the work that you don't have to do. Metadata caching. So every time ORDS serves a REST request, it has to look up the workload in the database, and it has to look up the the privilege that's protecting the resource that you're trying to access. So if I'm doing a post request and there's a PL SQL block of code under that, ORDS has to go look up to see what that PL SQL code is. So that's 1 to 3 queries to the dictionary to get that code and to also look to see what privileges are being used to protect that resource. If you're hitting that frequently, that's a lot of work we could avoid with a cache. So ORDS has a feature you can enable where we cache the definition of the APIs and we cache the definition of the privileges protecting the APIs. That can have a huge performance impact if you implement metadata caching. So the only problem with the cache, adding caches gives you a cache to manage and maintain. We have the default, I think, set to 30 or 60 seconds lifetime. So if you are in an active production environment where you're frequently updating the APIs, at most, you're going to be hitting an old version of your API for like a minute or two. If you're in an environment where you only update the APIs or the privilege definitions, quarterly, you could set the cache to several hours or a day. And those caches will be longer living. But the main thing is you can use this feature to avoid database work. Pagination. By default, the pagination size is set to 25. We use an analytic function to window the result sets for your SQL-based responses. Some folks like to create endpoints that have huge payloads, like they might want 10,000 records on a call, or they might even turn pagination off. Just keep in mind, the bigger the payload, and you have things like that hash compute enabled, takes a lot of CPU work on the mid-tier to construct all of the data from the results or from that ref cursor and build the JSON response and then carry it over the network. So you just need to be mindful of how you're using the APIs that you're delivering. What else do we got here? Oh yeah, and then the main thing, probably 80% of the time, Chris Rice or Chris Pointer and I are talking to an Oracle customer and they're needing help with optimizing or making their REST APIs faster. And this would also be true, for example, with the Apex community. Most of the time, Apex performance issues come down to slow running SQL or PL SQL in your pages. So we need to find that SQL, we need to find that PL SQL, and we need to tune it or optimize it for the REST API experience. So let's talk about that real quick. Oh, yeah, it could be your SQL. So your REST APIs are implemented with either our SQL code or your SQL code. If it's an auto REST endpoint, I'm not really set up to talk about here today, but things like indexing schemes and statistics come into play. But if it's your code, if it's your REST modules, your REST templates, your REST handlers, inside that definition of the code block is going to be a PL SQL block, an anonymous block that's going to be calling stored procedures that are running SQL, or you're just going to have straight up SQL statements. And you're going to be able to use the same diagnostic and tuning features in the database that you would be using to doing your normal database tuning work. So let's take a second and show how you define this stuff. The architecture of ORDS, we have two users. We have ORDS public user and we have ORDS metadata. And technically, ORDS metadata is just a flat out schema. ORDS metadata is never running runtime. Like no one ever logs in or does anything as ORDS metadata. Every session starts out as ORDS public user. Your REST APIs are executed as the schema to which they're published. So if I create an app schema, if I REST enable it, if I publish REST APIs in that app's schema, and then I start if I start exercising APIs from that schema, when I go look in the dictionary views, you'll see the SQL IDs, you'll see the SQL monitoring reports all popping out as that user, not as ORDS public user. ORDS public user is just there to populate the pools. The first thing that happens is ORDS takes that connection and it proxy connects to the app schema or the REST API. is defined, and it executes the database workload as that user. So if all you need to know to write REST APIs as SQL and PL SQL, it can be really easy to also write slow REST APIs if you're putting less than optimal database code in there. So to find that, in a lot of the dictionary views around SQL statements and sessions, you're going to see an action and a module column, and we populate that with the template of the API. So like the section of the URL that's tied to the endpoint. And we also populate it with the verb. So the get, put, post, or delete, or I guess also if we're using our new 23C JSON duality views feature, we also support patch. So if I were to go pull up a select blah, blah, blah from active session history, which is a diagnostic pack view, or even if I just pull out $SQL, I could see in there on the module column, the URI template fragments. So I've got one in here called query parameters multiples. The SQL ID that's attached to that is here. I've joined in the SQL text. This is just, straight up SQL statement that I've put to grab this data out of the dictionary. So if we come back here, I've got a GET request that's taking way too long to run, and I want to tune it. Now, if I'm not actively suffering this issue myself, I might not know I've got bad endpoints out there. If I don't have customers complaining, oftentimes you do know they are complaining, but if you need to track that stuff down, you can check the AWR reports, you can check the ASH views, you can check the SQL monitor, or you can just go into the $$ views to pull these things out. So I've coded up a bad REST API that's taking almost 15 seconds to run. So I've got my employees collection, and I want to pass a query parameter of a list of employee IDs. And then I want to pull out the employees where the employee ID is in this list. And I'm using a regular expression and connect by on another regular expression to do this. This works great when it's like 3, 4, 5, 10 employees, but I pass to it 999 employee IDs, which is kind of a no-no in Oracle. It's much better to pass in another SQL statement to represent that list of employee records. Now, silly me, I knew this was going to be bad, but I didn't know how bad. So I inserted artificially the SQL monitoring hint. So I would get a real-time SQL monitoring report when I ran this. After I ran it and I saw it was taking 15 seconds, I totally didn't need the monitor hint. But when I go pull up the report, I can see the code that's being run, and I can get all of the database level stats back. So I can see that CPU wasn't great, and the PGA, the memory allocation for my process, was pegged super high. That's not good. But I could also have access to the plan statistics and the plan steps. So if it wasn't me doing something stupid, if it was more like I needed some histogram buckets, created in the stat so the optimizer could pick better execution plans or pick the index I want, that kind of information would be in here for me as the SQL or the PL SQL, developer to see that and fix that. So the other thing that we do to make this stuff easier to find is we generate an execution context ID, the ECID. This is another column in those $, views. And this allows us to create like a chain of custody, or like a maintain a transaction from across the different layers. So by layers, I mean like the web server and the database. So at the web server layer, there's a GET request. And at that point, we generate these ESID value. And then we also pass that into the database. So when I'm looking at this ESID column, these strings here would match up theoretically. So you can go through your web server logs and find those and pull out the ESIDs. Let's talk about connection pools real quick. So this is maybe the hardest part of tuning ORDS in your REST APIs for your database, and that's properly sizing these. So do not just blindly increase your connection pools. This can actually make things worse. So the whole thing of a connection pool is we can use a smaller number of connections to support a larger number of users. Knowing the sweet spot, it comes down to some basic math. One of the biggest impact factors in that is how fast are the transactions? How fast is your SQL and PL SQL? And then the second piece of that is how fast are requests coming in? If you've got a really slow running request, maybe not as slow as mine was 15 seconds. That's really bad. But even if it was like 1.5 seconds, that's not good. It'd be better if it were like 1/10 of a second. If you've got a connection pool of 100 users and you've got 101 people coming in, that 101st person is going to be blocked, and so is everyone else for like the next 1.5 seconds. We talk to customers that want to be able to execute 800 or so transactions a second when retail season really kicks in, but they don't need a connection pool of 800. What they need is a stored procedure or a SQL block that does the ETL transaction in fractions of a second, so that even as these hundreds or thousands of people pile into the system, we're not fighting over connections in the connection pool. So we could do an entire 2-hour session just on properly sizing pools, but we don't need to do that because that's already happened. We'll get these links in the Slack channel, or at least I will when I'm done talking, and kick it over to Chris. But the real world performance team has a really nice overview of properly sizing connection pools. Now, when you go into ORDS and you start it up, sometimes you'll see warnings and it'll be calling out, hey, you're using the default pool sizes. But if you also come into ORDS and use the command line interface and you say, hey, list me all my different properties, if you see the max limit here set to 20 and the initial limit set to 3, you're running with the default settings, which is really just only good for like developers messing around on their own machine. It's not going to be good for almost any production environment. Okay, so I'm now happy to segue over to Chris, and he's going to talk about if you were to implement some of these performance improvements, or what you think are performance improvements, how could we test or validate that those fixes result in the more users being able to do what they want? All you, Mr. Hyman.
Thank you. Yeah, thanks, Jeff. Let me go ahead and just get everybody on the same page here. So we're talking about these tools that you can use with your ORDS REST APIs. And over the last, I would say like a month, I've been working with 3 different tools, particularly Artillery, K6, that's like the last week and a half, and then JMeter, the same thing last week and a half. So I'll start with Artillery. This is in no particular order. This is just the one that I started with. So this is Artillery, the first one, npm install YAML. We use YAML files for scripting, which you'll see here in a second. Comes built in with plugins and extensions. The 3 that I was really focusing on for testing the ORDS performance metrics were Ensure, AppDex, and metrics by endpoint. So like AppDex is like an industry standard. Cool thing about Artillery, it seems to be a younger organization, but it's all open source. You can do things, you can do all your testing locally. You can do things via the cloud as well. They got a nice cloud dashboard product, which is kind of neat. So this is open source. All these tools are open source. But But just as an example of like what this YAML file looks like, this is it. So this is actually one that I was kind of playing around with. You can see it consists of just two different portions of this like script. The first is the configuration section, and then there's like the scenarios section. If you take a look there, you can see target and then localhost 88 ords. Actually, I have ords running right now, but that's like my base URI for these APIs that I was testing. And I'll show you here in a second. I'll go into database actions, and you can see like the modules that we created and the functions that we created to kind of like, I don't know, spoof these tools, into faking like these really long transaction times. But those are the two templates and the handler code, the handlers down there. So we've got basically one function that waits for 1 second before it produces a request or before it like sends a response. And then the second one, it actually waits 1.75 second before the user will see anything. So yeah, that's YAML. That's the one that I had the most experience with, just because it's the one that I started with first. K6 Grafana Labs, also an open source product. It's a little bit different. Installation is just as easy as with the as with Artillery. But this one's primarily not primarily, this one is in JavaScript. So for me, not having any JavaScript background, this was challenging to say the least, but they do a really good job with the documentation. And this isn't like I'm not trying to sell anybody on any one tool. I mean, of all these tools, any tool is better than no tool, right? But they're all very similar. The output's a little bit different, the command line, but they have the built-in metrics. You see like the latency, and they also have like some of the AppDex stuff, like failed and successful requests, and they have some information on like virtual users and different iterations and things like that. But there's a lot more that you can extend the functionality with JavaScript. There are a lot of open source plugins and extensions. You can do this locally. You can run these tests distributed also. They have a cloud dashboard. You can offload a lot of the cloud, a lot of your load testing to their cloud as well, which I thought was pretty interesting. This kind of this is like the basic script that you get when you first install you're playing around with K6. So it's like what, 5-6 lines of code. As you can see, they've got an open API that you can go to. It sleeps for a second, and then it will iterate however many times that you've named how many virtual users that you've like established for this. So it makes it really easy, because like if you have your ORDS API, you can just plug your GET requests in there, and you don't really have to change much. So I thought it was pretty neat. But if you have like query parameters and things like that, they make it easy for you to. It's all JavaScript. Knowing what I know now, is like the possibilities are endless with this. So it's pretty interesting. And then the last but not least, JMeter. JMeter is like the godfather of these performance tools. Maybe starting to show a little bit of its age. I mean, it can do anything you want. I mean, it is like so comprehensive, it's overwhelming, but the bright side, they do have a GUI, so you can build your tests in this GUI, and the documentation there is absolutely no shortage of documentation or wikis, or there's like a Confluence page, GitHub, tons of stuff. But you run all these tools in the command line. You can see there's kind of like there's something that's streaming in the bottom there of the command line. So, and I'll just go ahead and just run through this. This is you're going to get the slides. I'm not going to read like every single thing here. But the idea here is just like a brief overview. You can see it's kind of like color coded, but like you got like a brief overview, what it can output in. So this is Artillery that we're looking at. And then my perspective, like those last three are my perspective. So it really didn't take me too long to get accustomed to Artillery. You can see how like most of the time was me just getting comfortable diagnosing and troubleshooting and kind of experimenting with the scripting. So the YAML was like really, it was easiest for me. And I associate YAML with like CI/CD. I've first heard about it in Ansible playbooks. So if you're coming from, if you like that type of persona, then maybe that might be like something that you want to like start off with first, you know. And like I said, I'm not necessarily recommending one tool over the other, but it might be a good entry point for you. And then you can see some of like the final thoughts there, you know. So virtual users are a little different in artillery as compared to K6 and JMeter. And they have a whole bunch of documentation and like the methodology for why they do the way that they do that. And then K6 is like I said, it's all JavaScript. I mean, the possibilities are endless. Really, the possibilities are endless with all these tools. And then outputs, you have like basically any text format that you could possibly want. This one and JMeter probably took like the two longest for me, just because I don't come from a JavaScript background, so it was a lot of just like learning JavaScript in this context. But you notice like a lot of the stuff is repeatable, so you can kind of pick it up pretty quickly, you know. And I'm still learning a lot of the different constructors and things like that when it comes to like the scripting, you know. So the learning curve is a little bit steeper for this, but like I said, after about a week, you should be able to run like a very, very basic test. And I'm starting to toy with like the virtual users and iterations and like how many like of these virtual users I want to send to the API, and you know, so it's getting easier. And then finally we've got JMeter. I mean, JMeter's just been around forever. The scripting's in JMX, so I think it's a little bit more challenging, but once you know what you're looking for, it's not too bad. Very, very steep learning curve, just because it's so like methodical, you know. There's everything is like an individual little module, a little component. You can just kind of add things, but you really have to know where to look for. Absolutely no hand holding whatsoever. So I'm still learning. YouTube is your friend when it comes to JMeter. So I think it's broadly applicable to whether you're development or ops. So I think it just kind of blurs the lines or straddles the line, so to speak. I can pause there and see if anybody has any questions or anything. I'm not really monitoring the chat, but I guess I'll just
Yeah, you're good. Keep going.
Okay. All right. So I'll pause there. Like I said, you're going to get a copy of this presentation here, and I'm going to show you very, very quickly to be less erratic with my screen movement here. Show you very, 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 very briefly like what we have, like setting the stage. All this stuff's going to be in my blog repository. So if you're on the Slack channel, once this is done, I'll drop a whole bunch of information in there. So you can just review now, but you'll have everything. You'll have like the SQL script that I created to create these modules, but this is the one here on the right that we're looking at. So we created 3, but I'm only using 2 here for our pre and post tests. But you can see that's the base URL here. And then if I go to my one template, and these aren't like the best named APIs, but just try to make it as obvious as possible. And I click on this, I can actually see this handler code here. So I'm not sure if you can see. I'll just like increase this a little bit. Yeah, but we're just using the DBMS _ session procedure here, and we're just saying sleep for a minute, and then the output message that the user or the client is going to receive is going to be that sleep for 1 second message. Okay, and then if I can use these breadcrumbs here at the top of the REST workshop to go back to this main dashboard here. And then if I click on 175, you can see it's same thing. The only thing we changed is just we just changed the seconds. So it's 1 3/4 seconds. Okay. So that's kind of like setting the stage for like, this is what our APIs look like. And you're probably asking like, well, why did you do this? Well, like, I'm too dumb to come up with fast SQL or slow SQL. So like, this is just like the workaround to spoof our testing tools into saying like, hey, we started off with really slow SQL and it took 1.75 seconds to produce something. But then we used Performance Hub, we used AWR, we had some sort of database monitoring tool that clued us in and told us that the SQL is very slow. So then we made those changes, we push it to master, and then boom. Now we've shaved off 3/4 of a second. It's probably still pretty crappy SQL, but this is like an onion. You're just like taking off layers. So any little bit that we can do is helpful. All right, we're gonna skip this here. This is the output, and I'm gonna show you actually the tests that we did. Hopefully, I'm going slow enough. Okay. So here is this is my blog repo. So if you visit this, and you can create a branch if you want, or you can add in some comments and things. So we're going to go to ORDS performance, and then we're at the November 2023 webinar, and I'll just collapse these. Okay, and you can see we've got artillery, JMeter, and K6. So we'll start off with artillery, just so you see kind of what I created here, and I tried to comment this as much as possible. But that's our base path, like you see there, right? We're in the config section of this YAML file. And then it's really easy if you want to create these phases. So like basically we're starting this warm-up phase, and everything's in seconds. So we're saying, all right, for the first 60 seconds, we're going to have an arrival rate of 1, and then we're going to of 1 virtual user, and they're going to ramp that up to 45. So we should the easiest way to look at this is if you divide 45 by 60, that's how many virtual users you'll see per second. Okay, what is that? It's like 45 divided by 60. So it's 0.75 users per second, right? New users per second. And then you can see what we're doing here. We're sustaining, and then I'm just doing like this ludicrous ramp up here. I don't have service levels like you might have, so I'm just making stuff up. But you'll want to create something that is like real world. And then you can see we've got the plugins here. I haven't changed anything, but like you can see, like we've got response time. So we say, okay, that, like as an example, this means 99% of the time we want that response time to be 100 milliseconds or less, right? All right, and then here is our what I'm calling our post test. Our pre-test would be down here. If I uncomment this, you can see. So I run the test with the pre-test. This is like the crappy slow SQL, right? And I output that, and then I run that. I run it a second time with the improved SQL. Okay. So that's what it looks like for YAML. I found it very, very easy, very, very approachable. It's really easy to put your ORDS APIs in there, and then just put your endpoints in here, your URIs down here. And then the next one is JavaScript. So if you come from a JavaScript background, you will probably immediately understand what's happening here. I did find this plugin that you can use to output the report in HTML, which you'll see here in a second. It's very nice. And then they go about this a little bit differently. You can structure this different ways, but you create this constructor here, and you've got these different stages. You can do these in minutes or seconds. But basically, it's implied that you're starting at 0 virtual users, and you're trying to reach a target of 60 in that 1 minute. You can see I do like another ridiculous ramp up here. And they've got some thresholds here. These are just for, just different metrics. And then if I slowly scroll down here, this is what this looks like here. Now, I left this sleep in here by the off chance I was afraid that maybe I might break something, but this is just mirrored off of what the example shows. So I left it in there. So if you know JavaScript, let me know if I can take that out, but I don't want to break anything. So this is our pretest, right? So 175. So you see how it's the entire URL here. And then this is basically just me saying, okay, take all that, export it to a HTML report, call it pretest. Okay. And I did the same thing for the post test. Yeah. All right. Now, what you've all been waiting for, the JMX file. There you go. Have that. I'm kidding. This is what it looks like when you save. So if you're in the GUI, you can click things and save your JMX report or your JMX file like this. But if we kind of scroll down here to like line 24, you can kind of see what's happening. I guess if you've done anything in React, then you're familiar with JMX. But so this is all my host import information, and then this is you see there, it's the same thing. So this is my pre-test. This is 175. And then you can see in here, I've got, I mean, this is just an absolutely bonkers strategy here, or load test that I have here. Even if you see at one point there, I'm saying, all right, let's introduce at 1,000 virtual users a minute. Let's go ahead and introduce at that rate, and we're going to do that for 20 seconds. So it's a Black Friday event, maybe, I don't know. Taylor Swift tickets, maybe, I don't know. It's just bonkers. Okay, so that's what that looks like. And then if I remember down here, I've got all the module stuff. So if you want to just like play with this, you can just execute that in your SQL worksheet, assuming you have the two tables I have. I'm using the employee and the departments tables from Live SQL, actually. All right, so I ran all these tests, right, and I saved them here. So let me show you. How much time do we have? All right, let me just show you here really quick what we've got. All right, and they all present this a little bit differently, but it's actually fascinating how you can see the before and after. So on the left side of your screen here, we've got the before tests. On the right side of the screen, you've got the after tests. Okay. And if you know anything about AppDex, you'll see that we've frustrated this user so that, like, for instance, this first line, which resulted in a user just saying, "Oh, screw this. I'm going to come back later." But here's the beauty of this. Here's the beauty of this performance test. You take a look and you say app frustrated. The value, we have 786 instances where that happened, right? And if you look at the right, we say we've got 1132. Well, that's crappy. But yeah, in isolation, that looks like crap. But the reason why it's higher is because your rate is higher. So like, let's look down here, like HTTP requests. We actually have the same amount of HTTP requests in this case. You see that? What you'd expect, because we didn't change anything with the rates or anything. But in our pre-test, we had 86 responses. So that means of those attempts, 786 actually received some response. Now, it doesn't necessarily mean they received a 200, which is good. It just means they received some response. Whereas here, you see, we got a lot more people through. And in this case, we have, more users received a 200 code, right? A successful than on this left side here than users. So I thought that was pretty interesting, but I'm not going to go through every single thing here, but you can see how in both cases, it's pretty crappy SQL. You can see how, like, we're pissing people off at the very beginning here. So as an example of this, at this on the left side, what does this mean? So if I hover over this, you can see, like, at that 50th second, we had 140 users that were pretty pissed at us. Right. And I can just kind of keep coming down here like this. You can see how, like, how as we increase the rate of users, the timeouts increase, things like that. So I mean, this is just it's just endless, right? So we've got the HTTP request. You could see that. So it's pretty fascinating. So that's one way that that you can present this information in an HTML. You can actually output this to a JSON as well. And then here's K6. This is actually a plugin, so I'm not sure how official we can call this. But again, on the left side, you see got these nice things here at the top where we say total requests. So you can see the rate differential. And again, in both cases, they're pretty crappy. But if you take a look at like other stats, this iteration right here, I mean, this is 14.6, 14.6 iterations per second, 14.6, pings to that API per second, as compared to an increase, we see 20.91. So that's, I don't know how you want to interpret that. That's microtransactions in Call of Duty. That's FTX transactions. That's like to an enterprise, that those numbers can mean a lot. They're pretty significant. And then finally, Apache, guys, we could spend the entire hour with Apache JMeter, because you can select any single test that you want. I mean, you can see all these charts that I have here. I'll just select the over time chart, because there's like charts within charts, and you can see it's actually pretty funny, because you say, like, on the left side here, like, wow, that's a more favorable graph. Yeah, but look at this y-axis though. The average response time is that's 46, almost 4,700 milliseconds compared to the highest here is what, less than 1,100 milliseconds, you know? So there's a market improvement according to this dashboard. They're both pretty crappy. You know, they're both pretty crappy endpoints. You see how the request summary, we have, you know, we have more failures on the left. You know, however you could see, like if you look at certain things like yeah, you could see like the response times and things like that. So let me what's our time here? 12:48.
10, 12 minutes left.
Yeah, so the last thing I'll mention is Jeff was mentioning is, and I've got words up and running here, is, you know, you make a change, you push it, you make a change to SQL or something happens, and I think the natural tendency is to just say, okay, well, if I'm testing this locally, I'm just going to say, all right, I'm going to go to ORDS, I'm going to look at the configuration and like, what are the things that I can mess with in the configuration? Here, let me just increase this here. So there are a few things in here with like here you go, like like JDBC connections. Like, yeah, you could do that. You can increase the number of connections and, you know, do things with cache and min limit and things like that, and then reuse count, you know, but then you're getting into like memory leakage and you're getting into like the expensive, you know, the expense of like holding connections, you know, or increasing connections. And, you know, and then the, like that has cascading effects, or that has like the unintended outcomes or effect of preventing other connections in other areas of your enterprise. You know, like you don't think of, maybe you don't, I mean, I'm sure people think about it. Please don't think I'm condescending, but like it's a slippery slope, you know, is what I'm saying. So that was that's the point that I'm
Number
getting.
one, don't mess with these settings if you don't understand what they do.
Yeah.
But maybe if you don't understand quite what they do, then the testing tools can probably shed some light on that for you.
Thank you everyone so much for joining us here today, and we hope to see you at the next one.
Cheers.
Thanks, guys. Thanks, Tara.